Hello, in this presentation we'll be discussing Bernoulli trials and the binomial distribution. Bernoulli trials are random phenomena with two outcomes. These could be the flipping of a coin that has the outcomes heads or tails. Having a baby, you generally will have a boy or a girl. If you attempt a backflip off your brother-in-law's deck, you will either fail or win. And if you ask someone whether they support the current president, they will say either yes or no. Notice that each of these random phenomenon have two different outcomes. That is a Bernoulli trial. Almost any random variable can be thought of as a Bernoulli trial. Consider hair color. Hair color is a qualitative variable. However, if you're interested in a particular hair color, say black hair, then the hair color variable becomes a Bernoulli trial. Specifically, if you find someone with the hair color black, you could consider that a success. And if you find someone that the person that you meet does not have black hair, then that's a failure. Generally, we think of Bernoulli trials in terms of success and failure. However, success doesn't necessarily mean a good thing. For example, if you're studying airplane accidents, you might say that a success is that the airplane has an accident, and failure is that the airplane does not have an accident. That's just terminology. We really don't mean that we want the airplane to have an accident. It's just what we're looking for in the particular study that we're doing. A binomial random variable is actually a series of Bernoulli trials. Think of a pollster who has gone out to ask people their opinions of a particular president. They are doing a series of Bernoulli trials, asking numerous people the same question and writing down their answers. The random variable that describes the number of successes in Bernoulli trials, in which the probability of success is lowercase p, is a binomial random variable. We need those two letters to represent the number of trials, maybe the number of people we're going to ask about the president, the number of times we're going to attempt a backflip off our brother-in-law's deck, or the number of people that we observe in order to figure out how many black-haired people go to our school. We need to know that number, and that's going to be lowercase n. We also will need to describe the probability of success in a particular Bernoulli trial, and this is going to be represented by lowercase p. This could be the probability of actually completing a backflip off your brother-in-law's deck, the probability of making a free throw if you're playing basketball, or the probability of finding someone who is pleased with the president's performance. The symbols that we use to represent a binomial random variable are here, and you'll notice that we're going to use capital B, and in parentheses we will put the two numbers, lowercase n and lowercase p. Normally we'll use numbers for those, not letters, to represent the binomial random variable. We use a tilde to say that our random variable can be represented by the binomial random variable. The probability of this binomial random variable is given by this formula, but don't get scared. We're not going to use that formula. I just show it to you to illustrate what the calculators will do for us. You could use that formula to compute the binomial random variable, but we're going to use the calculator. We'll cover calculations in another presentation. This is just an introduction. But when we do the calculations on our calculator, we're going to use this distribution key, and you can find this in a separate video. But here's the syntax. To calculate the probability that a binomial random variable will take on a particular value, we use the binom PDF. If you do go to your calculator and use second distribution or distr you will find that there are two binomial listings. One of them is binom PDF, and that is the that will actually calculate the probability from the formula on the previous slide. The other one is binom CDF. That is the cumulative distribution function for the binomial random variable. In this case, you would be calculating the probabilities, the sum, the cumulative probabilities for a range of values, specifically the range of values that are less than or equal to whatever number you're interested in. We'll go over that in a separate presentation. Some examples of binomial random variables. If a hunter fires at 10 turkeys with p is equal to 0.1, what's the probability that he bags exactly 3 of them? In this case, we're interested in whether or not he bags or actually kills turkeys, and the probability that he kills an individual turkey is 0.1. The number of turkeys that he is firing at is 10. So in this case, n is 10, p is 0.1, and since we're interested in exactly 3 of them being killed, x will be 3. The probability that a student passes this course is 0.97. What is the probability that more than 10 students out of a class of 12 pass? In this case, this is a binomial random variable in which we are interested in 12 students, and so n is 12. P is 0.97, and I'm interested in more than 10 students passing, and so unlike the turkey example, in this case I'm going to use the binom CDF function. We'll talk about that more when we go over calculating binomial random variables in the next presentation. But for now, notice that n is 12, p is 0.97, and x, well, we're interested in 10, and we'll talk more about that in the next presentation. Finally, a basketball player is given 3 free throws. What's the probability that she misses all 3 of them? And in this case, we're told that p is equal to 0.6. That is the probability that this particular basketball player makes a free throw. So in this case, n is 3 because the basketball player is given 3 free throws. The probability that she misses all 3 of them is asking for the probability that you end up with no successes. And so x is 0, and p is given to be 0.6. If you need it, you can watch the next presentation that shows how to compute these probabilities as well as others. Or if you just need help with your calculator, look for the calculator video for binomial random variables.